Hello everyone, myself Professor Chavan. We have started the fourth chapter from our 11th Science CBSE board for the subject physics. Okay. In previous lecture, we have learned about the vector addition method, that is the polygon law. How we can add the vectors and for which purpose we can add or we can use the polygon law of the vector addition. Okay. So in today's lecture, we have to learn about the resolution of the vectors. Can we resolve any vector into its component? Or if we have the one vector, then is it possible that it is having its components? Okay, so we have to learn about the components of the vectors and its resolution. Okay. Okay. Suppose we have the one object, okay, and that object is under the effect of one vector. Okay. So if that object is under the effect of only one vector, then can that vector have the another two its component? Okay. If we have the one vector, then can that vector have the its two components? So if it is possible to have the vector as the its component. Yes, it is possible, because if we think about the one object, we have learned about the one example at the start of this chapter, that when we throw a ball in a upper direction, then in that case the ball is traveling along the y direction also, and also it is traveling in a x direction. But which is the final position of the ball, that we can see easily. Okay, suppose we have the ball, okay, and if we throw a ball like this, then in that case the ball is covering this higher vertical distance also and this horizontal distance. At this time it is having both vertical and horizontal distance. Okay, so it is having both vertical and horizontal distance. So but we are not able to see this vertical and horizontal distance separately, but we are able to see the final result, the final resultant of combining these two vectors, the final result of the addition of these two directions. Okay, so whenever we see any one object is traveling, then in that case there are two vectors are acting on it, and combiningly the effect we are able to see that the object is traveling in that particular direction. Okay, so in this direction we can see that the object is traveling in this path, but along this path there are two directions in which the object is traveling. The object is traveling in the x direction also. Okay, the object is traveling in x direction along this horizontal path. Also the object is traveling in the y direction. Okay, the object is traveling in the y direction. So whenever we see any object it is traveling, then we can say that it is having its two components. Whenever there is the one single vector, then it is not the one single vector, it is having its two component. Okay, so combiningly we can say that whenever we have the one single vector, we can find out the component of its vector, and if we have the two separate vectors, we can find out the final resultant of combining these two vectors. Okay, suppose we have the vector A and vector B, then we can find out the resultant of these two vectors. Suppose this is the vector A, okay, and this is the vector B, then in this case we can find out the resultant of these vectors by joining these 2 points, the initial point and the final point, and this direction is the resultant. Okay, we learned this in the triangle law, that we have to join the initial position and the final position, that is the tail of the first vector and the arrowhead of the second vector. Okay, and combiningly these two vectors addition will give us the resultant R, which is also one vector. Or in case of a parallelogram, we have learned that when the adjacent sides of a parallelogram represents the two vectors, then the diagonal of a parallelogram passing through the intersection of the tails of the two vectors represents the resultant. Okay, suppose this is the adjacent sides of a parallelogram, this is vector A, this is vector B, then in this case this is the meeting point of the tails of the two vectors, or we can say the intersection point of the tails of the two vectors. Then in that case the diagonal passing through this point will give us the resultant. Okay, the diagonal passing through the point will give us the resultant, and also we learned that these two vectors are making some angle theta with respect to each other. Okay, these two angles are making some angle theta with respect to each other. And what about its magnitude of the resultant? The magnitude is given by under root of a square plus b square plus twice ab cos of theta. Okay, and the direction is given by tan inverse of a sin theta upon b plus a cos theta. Okay, so we will get the magnitude and direction of any particular resultant. Okay, suppose we have the two vectors and they are making an angle theta, on that angle theta is equal to 90 degree. Okay, suppose we have the one resultant and its components are making an angle 90 degree with respect to each other, then in that case we can say that those components of the resultant are the rectangular components. Okay, suppose we have this. Okay, then in this case this is the resultant. Okay, this is the vector A, this is the vector B, and if we go to find out the resultant, the R here, we'll get R is equal to a square plus b square. Okay, resultant R is equal to a square plus b square, and where a is the component of this resultant vector along the x direction and b is the component of the resultant along the y direction. Okay, so in this case also you can see that if they are making the 90 degree with respect to each other, this is the component A, B, this is the A, then they are making some angle 90 degree with respect to each other, then you can find out easily that this is the component of the resultant along the x axis and this is the component of the resultant along the y axis, so that we can also write here that R is equal to A square plus b square, or we can say that resultant in terms of the vector we can say that Rx plus Ry. Okay, the resultant R is equal to Rx plus Ry, and by this we can indicate that the two vectors are there and combiningly they are having the one resultant. Okay, where Rx and Ry are the components of the resultant vector. Okay, and the position of the resultant vector we can find out by knowing the formula of this a square plus b square plus twice ab cos of theta. Suppose we have the one velocity which is having the path along the resultant, then in that case if the body is making some angle theta with respect to the one of the vector, then we can find out how much is the value of that resultant vector. Okay, so in that case if we see here, suppose we have one ball and if we throw that ball, then in that case if we throw this ball, then in that case what is the value of the resultant? It is R square is equal to a square plus b square. Okay, R square is equal to a square plus b square, or we can say that the R is equal to Rx plus Ry. Okay, R is equal to Rx plus Ry, And if we have the value of this resultant, suppose it is making some angle 60 degree with respect to the one of the vectors, suppose this is the Vx and this is the Vy, and it is having the velocity equal to 20 meter per second. Okay. Then if we have to find out the magnitude of its component, then how can we find out the magnitude of its component? We know the resultant is making some angle theta with respect to one component. So accordingly, we can write down as its component along the x direction is Vx is equal to V cos of theta, and Vy is equal to V sin of theta. Now what is the value of V here? We can put 20 cos of 60 and 20 sin of 60. Okay, V cos theta is equal to 20 cos of 60 and V sin theta is equal to 20 sin of 60. So we have these two components. Okay, and we have the resultant velocity here. Then depending on that, we can find out the value of its component. That is the resolvation of the any one vector. Okay, resolvation of the any one quantity. If we know its x and y direction, then we can find out the value of the resultant components if we know the angle made by the resultant with respect to any one vector. Okay, we know the value of the resultant here, it is the 20 meter per second. Okay, we know the angle between the one of the vector, one of its component and resultant. Then using that angle, we can find out V its component by Vx is equal to V cos of 60 and Vy is equal to V sin of 60, that is 20 cos of 60, and Vy is equal to 20 sin of 60. Okay, so we have the both component. We can find out both the component, and finding out such a component is nothing but the resolvation. Okay, finding out the component of the any one vector is known as the resolvation of the vector, because we are resolving the one vector into its two component. Okay, we are resolving one vector into its two components. Okay, so this is about the resolvation of the two vectors. Okay, resolvation of one single vector into its two components. Suppose we have the two permanent directions as the x direction and the y directions, and we have the vector A along the x direction and the vector y along the vector B along the y direction. Then by adding these two vectors, we can find out the resultant by using this formula. Okay, if we have the vector A along the x, okay, direction and B along the y direction, then its resultant is found out by r square is equal to a square plus b square. Okay, and if we know this component theta, then we can find out the rx is equal to a is equal to r cos of theta, and ry is equal to b is equal to r sin of theta. Okay, Rx is equal to A, R cos of theta, Ry is equal to B, R sin of theta. So, what is important here, that if we know the value of the resultant and if we know the angle made by the resultant with respect to any one axis, then we can find out its value of the component. That is the main motto about this topic. Okay, suppose we have the one vector, that is the resultant vector P. Okay, we have the one vector, resultant vector P, and we have to find out its value. We have to also find out its magnitude. Then how can we find out its magnitude? We know it is having the component of -2 along the x direction and the 4 along the y direction. Then in that case, how can we find out the value of this vector? We can find out the position easily, because we know along the x it is -2, along the y it is 4. Okay, so if we draw it graphically, we will get this is the one Cartesian system in which we have to show 1, -1, -2. Okay, this is the 1, 2, then this is the 1, 2, then 3, 4. Okay. So to find out, to locate this vector P, what we have to do? We have to find out the intersection point of this x component and the y component. So it is the -2. We have to draw the perpendicular line from this. This is the 4. We have to draw the perpendicular line from this, and this is the position of the vector P. Okay, this is the position of the vector P, and if we join this point with the origin, then we will get the position vector. Okay, we will get the position vector of this vector P. Okay, and what about the magnitude? For finding the magnitude, we have the formula, that is the P is equal to under root of x square plus y square. Okay, so we can find out that 2 square plus 4 square is nothing but equal to 4 plus 16, that is the under root of 20. This is the value of the P. Okay, P is the value, it is under root of 20 is the value of the P. So from this we can find out the position also. If we know its component, we know its component along the x is -2, along the y is 4. Okay, then we know we can find out its position by drawing it on the graph. Okay, so we can use the graphical method also to find out its position. Okay, and to find out the position vector, we just have to draw one line from its origin, then it will get up to this point, and line joining these two points is known as the position vector. Okay, that point we will see in a rotational motion also, but remember that this line is representing the position vector for that particular vector P. And what about the magnitude? We can use the formula r square is equal to a square plus b square. So accordingly the P is equal to under root of x square plus y square. So P is equal to -2 square plus 4 square is equal to under root of 4 plus 16 under root of 20. Okay, this is the magnitude of our vector P. Okay, and if we know the angle theta, then we can find out this in terms of the angle theta along the x components and the y components. The components of the vector along the, suppose we have this, we know this angle theta, then px is given by its magnitude under root of 20 cos of theta, py is equal to under root of 20 sine of theta. Okay, px is equal to under root of 20 cos of theta, py is equal to under root of 20 sine of theta. So from all this we can come to know that if we have the one single vector, we can resolve it into the its two components, and if we have the two components, we can get the one single resultant vector. Also we can find out its position also.